So here comes the conclusion. More than 5 minutes. So 4 feet. Would that be 6 times as much work being switched to? That would be 6 times.
No, you're just holding the bricks. I'll go through the I'll go through the paragraph again. In physics, work is defined as the product of the net force and the displacement through which the force is exerted, or work equals force times displacement. So it goes on. Suppose you lift 50 bricks to a height of 3 feet. You do this 50 times as much as lifting one brick that high. But this may seem hard. So let me just get to the point of it. If there's no movement, there's no work done.
Right.
All right. If I have a dumbbell and I'm curling it, the only time work is being done, according to physics, is when I'm actually raising it. All right. Because there's motion in my muscles, so the work is done inside my body. All right. But no work is being exerted on the bricks when I'm just holding it. Okay. So zero work is being done. Zero work is being done. All right.
Okay.
Now, work equals force times displacement. All right. So, all right. Questions we got are as follows. Jasmine, you will do the first one, and Shanika, you do the second one. Read and execute.
How much work is done in lifting a 3 to 10 cabbage 3 meters? It'd be 6.
And what is work? What is work units?
Is it joules?
Yes, it is. It is joules. All right. So 6 joules of work is done. All right. Now, Shanika, the second question is yours. Please read it and execute.
How much work is done in carrying a 12 Newton hammer while holding it at a constant 1.5 meters above the floor?
And what do you think the answer is?
Well, it says holding, so there is no work being done.
Yeah, there's no work being done because it's being held at a constant height. Okay.
So there's zero work.
Zero work is being done.
Okay.
All right, good job. All right. So let's talk about potential and kinetic energy. Jasmine, what is the formula for potential energy?
Mass times gravity, or that's what it is, height.
Mass times gravity times height. And I'll abbreviate this PE for potential energy. All right. Mass is in what units?
Kilograms.
Gravity is in what unit?
9.8.
9.8 meters per second squared. And height would be in what units?
Meter.
Meters. Very good. All right. Shanika, what is the...
Is it half times velocity squared?
1/2 mass times velocity squared. 1/2 mv squared. What units are mass in?
Kilograms.
Kilograms. All right, and our velocity?
Is this 9.8?
No.
No. Oh gosh.
Meters per second. She said, "Oh gosh." Who says that? Big Sean. Oh God, in his raps. I'm sorry, that's what that reminded me of. Oh God. Okay. Meters per second. Meters per second will be fine. All right.
Okay.
As you know, because they'll say, all right, well, let's say we have a 2,000 kilogram object, and it's moving at, I don't know, 4 meters per second. That's how a question we present it to you. They'll be like, what is the kinetic energy? How much kinetic energy does this moving object possess if it's a 2,000 kilogram object moving at 4 meters per second squared? That's how it could be presented. And you have to use your 1/2 mv squared. So why don't we go ahead and calculate that, folks? And tell me what you think your answers are.
Um,
60 seconds. All our math problems we want to knock down in less than 60 seconds. So we have 1/2. The mass is 2,000. The velocity was 4 meters, but in a formula, the 4 is squared. So what is 4 squared, Shanika?
16.
16 times 2,000. Just look at 16 times 2, find that number, and then add your zeros.
32,000.
32000. And then we have to have it. So 16000. 16,000 joules. That is the kinetic energy that this object possesses. All right. So you want to put like your formulas on flashcards. On some testing, they will provide you with formulas, but I'd rather you just know them so you don't have to waste time looking for stuff. So you should have potential energy and kinetic energy etched in your brain. Okay, so let's do another one with potential energy. We'll erase this guy. We did kinetic. So let's say we have an object, and this object is on a 100-meter cliff. And this object is 5 kilograms. All right. What is the potential, and Jasmine, this is yours. What is the potential energy of this 5 kilogram object? First of all, tell me what formula you're going to use, and then plug in the information. I can't hear you if you're talking.
Potential energy formula,
Yes, ma'am.
which is m times g times h.
All right, so our formula is mass times gravity times height. What is the mass?
5.
Oh, God. It lost power.